Jet engines are the powerhouses behind modern aviation. They enable airplanes to travel at incredible speeds, transport millions of passengers daily, and power military aircraft for defense and exploration. Understanding how a jet engine works is a fascinating dive into physics, engineering, and innovation. A jet engine is a type of reaction engine that generates thrust by expelling high-speed exhaust gases. It works on Newton's third law of motion. For every action, there is an equal and opposite reaction. The engine pulls in air, compresses it, mixes it with fuel, ignites it, and ejects it at high velocity, propelling the aircraft forward. Main components of a jet engine. Jet engines are made up of several key sections, each playing an essential role in the process. Air intake. The front section that captures incoming air. Designed to slow and smooth airflow before entering the compressor. Compresor. A series of spinning blades, rotors, and stationary blades, stators, compresses the air to increase its pressure, making combustion more efficient. Combustion chamber. High-pressure air is mixed with jet fuel and ignited. The burning fuel-air mixture rapidly expands, producing hot gases. Turbine. A series of blades connected to the compressor by a shaft. Hot gases spin the turbine, which in turn powers the compressor. Exhaust nozzle. The gases exit at high speed through the nozzle. The jet of exhaust produces thrust that propels the aircraft forward. Principle of jet engine operation. The working principle of a jet engine is based on Newton's third law of motion. For every action, there is an equal and opposite reaction. Action. The engine takes in air, compresses it, mixes it with fuel, ignites the mixture, and ejects the hot gases backward at high speed. Reaction. The backward push of gases creates an equal forward push, producing thrust that propels the aircraft forward. A jet engine works through 4 continuous steps, often summarized as suck, squeeze, bang, and blow. The first step is intake, suck, where air enters the engine through the front intake. The intake is designed to capture a smooth and steady flow of air, slowing it down if necessary, especially in supersonic aircraft. This airflow is essential because oxygen in the air is needed for combustion. Next comes compression, squeeze. The air is passed through multiple stages of compressor blades, which increase its pressure and temperature. By compressing the air, the engine ensures that combustion will be much more powerful and efficient. In modern jet engines, the air can be compressed up to 20 to 40 times its original pressure before entering the combustion chamber. The third step is combustion, bang. In this stage, the highly compressed air enters the combustion chamber, where fuel is injected and mixed with it. The mixture is then ignited, creating a continuous burning process. This combustion rapidly expands the air and produces extremely hot gases, sometimes reaching temperatures above 2000 degrees, 3600 degrees. The expansion of these gases creates a tremendous release of energy. Finally, the process ends with exhaust, blow. The hot gases flow through the turbine, which extracts some energy to power the compressor, and then rush out through the exhaust nozzle. As the gases exit at very high speed, they create a strong forward thrust according to Newton's third law of motion. This is the force that pushes the aircraft forward. Jet engines are marvels of engineering that have revolutionized transportation and defense. From intake to exhaust, every stage works seamlessly to turn air and fuel into powerful thrust. As technology evolves, jet engines will become cleaner, faster, and more efficient, continuing to shape the future of aviation and space travel.